Okay, we've talked about the average of a set of data, the mean, the median, and the mode. Today we're going to talk about how much things deviate from the mean. The deviation of a piece of data is how far it is from the mean. For example, let's say if the average man is, let's say, 6 feet tall, and I am 5 foot 9 inches, I deviate by 3 inches. I am 3 inches away from average. How much things vary from the average? If the average income is $30,000 a year and you're making $20,000, you are $10,000 less. If you are making $50,000, you're $20,000 more. You say you deviate by either $10,000 or $50,000. What I want, one of the cool symbols in mathematics is the plus or minus button. And it's very, very useful for indicating that you're not sure about the answer of something and you give a range of it. You know, the time to get a car inspected is, I'm going to say, 45 minutes plus or minus 30 minutes. What does that mean? That means it is anywhere from 45 minus 30 minutes to 45 plus 30 minutes. That is, it's anywhere from 15 minutes, you show up and they take your registration, they take your keys, bang, they come back in 12 minutes, you wait in line, you pay for your car, totally done in 15 minutes. That's pretty rare, but it could happen. All the way up to 1 hour and 15 minutes. You wait and wait and wait and wait and wait, and finally they take you, and it takes forever. Now, I'm not saying that this is totally right, but you can give something with a range. Let's say a restaurant meal. A restaurant meal, at least at the restaurants that I go to, costs, let's say, I don't know, $12 plus or minus $5. When I go out to eat, I don't generally go to restaurants that are less than $7 an entree, and I don't go to restaurants where it's more than $17. So it's anywhere between 12 minus 5 is 7 to 12 plus 5 is 17. And I go on the low end of the range, I'll tell you, but that's just me. So this plus or minus kind of thinking is the heart of standard deviation. The standard deviation of a set of data is how much plus or minus from the mean. So if the mean, for some reason we always use x bar, and the standard deviation is, for whatever reason, sigma, one of the Greek letters of the alphabet. We want x bar plus or minus sigma to cover about 2/3 of the data. Now, some kinds of things have a large standard deviation, some kinds of things have a small standard deviation. A large standard deviation means there's a tremendous variety. If I said, how many friends do people have on Facebook? You'd say, oh, they have, I don't know, 400 friends, give or, it might be give or take, 1,000 friends, give or take 500. Is that what it would take to cover 2/3 of all the people on Facebook? That 2/3 of the people, you have to go, from 500 up to 1,500. That varies widely. Some people have a lot of friends. Some people don't have as many friends. Height, on the other hand, you don't have to deviate by 500. You have to deviate by about 6 inches, not even 6 inches. Plus or minus 6 inches is 6 inches up, 6 inches down. 2/3 of the adult male population is within a foot of 6 feet tall. They're somewhere between 5 feet and 7 feet tall. The standard deviation is probably even less than that. It might even be 4 inches. It might be 4 inches up or 4 inches down. So that is the rough idea of standard deviation. I'll be more specific in a bit.